All right, you math now. One of you goons over there left a yellow notebook. There you go. Yeah, goon. You goon. Is it actually dead? Yep, that one needs to be pried open. Fairly quick. Is anyone still going?
1 second.
Okay. Okay, because we just kind of started into 5-5, so I didn't want to put anything up there. Are those actually any good? Like they're usually one of the first to disappear, and I've never had one.
I was doing the completely wrong thing.
There you go.
I did not see the piece. Oh, old guy reaching back for his wallet. Have his hand back, reaching for the. When I thought that.
Okay, well, we're waiting for the last one or two to finish up. Been having some interesting conversations lately with students and one or two parents, a couple other teachers, especially the ladies in the room. How many times I want you to think about this, a teacher or a parent told you, stop playing with your hair, stop fidgeting with your hair, stop picking at your nails, sit still, okay? To the group as a whole, how many of you right now, your foot or your knee is going 100 miles an hour? How many of you are chewing on your hair, twisting your hair, doing that kind of stuff? Okay, guys, especially ones that grow it out like that, how many times you just kind of boing, boing, play with it like that? Okay. Just curious. The more I talk about it with some folks, there's been an increased interest in some potential, like, student organization for neurodivergence. Tourette's, bipolar, ADHD, autistic, and something where kids could just kind of wander in and talk about it openly without stigma, because you get told to behave a certain way and you don't have to, because all of that is perfectly normal. Girls especially are usually pounded on by social norms and told you must act this way or else. And it's something that's been on my mind lately. I was just curious if any of you were like, yeah, you're one of us. Just curious. Particularly the number of kids in here that we are on the track for Algebra 2 to Pre-Calc to Trig Calc junior year, like probably some of the upper half or upper quarter of your class academically. Boy, the pipeline from gifted to driven to burnout to emotional wreck in therapy in your 30s and 40s, that's a thing. And I would like to help prevent that if at all possible. So, who got caught in the trap?
Not me. Not me.
0 as a placeholder. I saw a good chunk of you who were like, oh, crap, and then went back and caught it. So that's good. There is no x cubed term, so I need a 0 as a placeholder. And when it says to find p of 3, be careful. What are you using for your divisor? Just 3. Don't change it. Okay? We only change it when we're talking about the 0 of a factor. This is specifically saying just use 3. Okay? So, off we go. Multiply, add. Multiply, add. multiply, add, multiply, add. And that's it. The answer is just negative 165. So, short and sweet today. A, did you actually set it up synthetic? You did not just plug 3 into the polynomial. You did it synthetically. Did you use the correct value, not negative 3? Watch your arithmetic. Final answer. Did you get that 0 as a placeholder? Okay. Y'all feeling good about this stuff so far? Like, you have to know how to do synthetic division and then quadratic the bejesus out of stuff to do what we're doing the next couple days. Okay? All right. Let's do this. No one asked anything that I remember on her mind, so, or, no, wait, there was a question, and I fell asleep. I'm sorry. There was a question. What was the question? You did ask, and then I passed out. No, it was a long, like, it was a conceptual question. Okay, 15.
Yeah, we've done 62 twice.
Oh, okay. So if you do the work to say, here's all the possible rational roots, to know that there are no rational roots, like, it's one of those proof by contradiction things. Do I have to show that every one of them doesn't work? No. Was it a cubic or quartic? Original problem. Like, cubic or quartic? Oh, okay. What I would do, just to show that there are no rational roots, like, say I do all the work, I list it all out, I go look at my screen, and I see something like this. That is clearly between 1 and 2, right?
Yep.
I would just try those. I would synthetic division with, like, 5/3 and, I don't know, 15/8 or whatever they are. I would just try those to show them that they don't work, because those are the only ones that were possible right there. Like, there's no point in trying -5 when it clearly isn't -5. That would be the most work that I would see. Is you try the one that you felt lucky about, and it didn't work. There was nothing close to it that worked. There are plenty of times where there are no rational solutions. In fact, as we're moving into the next couple of days, we might have a quartic that has 4 imaginary zeros. So not even rational, but just straight up imaginary. Okay? So that's why I said we had to make sure that we understand this stuff. Because if you know how to synthetic division and you know how to quadratic of all types, you should be okay moving forward. All right? So we left off with what? Using the rational root theorem, I know we got here at least. Did we do the got it to, or did we just do the example to? We did both? Okay. Show me some thumbs then. Are you cool with that whole rational root thing, or just probably another one or two to be safe? Yeah, they all start with 1 though.
Probably 1 or 2 to be safe.
Boo.
Change it. Don't do it.
Let me make sure that it works.
We want it ugly. We don't want it ugly.
Right, bro. Go ahead, right, bro.
8 minus 3, 5. 6, 5, negative 10. 65, negative 10, 5, negative 4. Six, 5, negative 10, 5. There.
Mine's like 2 X's. XX. What do you mean, why is
Oh.
That's
There's 2 X's because I can't think straight. You do the rational root thing on this. I'll be back in 3 minutes and 30 seconds because I downed a couple numbers.
Sir, 3 minutes, 30 seconds. I'm right. Where do you write this at? I know how you do
like the little squiggly lines. Yes, guess what? Chicken butt. No, that's the biggest butt in my life. Oh, really? Yep. Did you? Yeah. 6 by 6. Show me. G2. 1, 2, 4. Yeah. Show me. So I understand the drop her up.
Okay, to find one, you do select one is one.
Okay.
So 1 over 1 is 2 over 1.
Not alive.
It's only an extreme, right?
I've already shot.
Probably
Well, I started. I dropped
I know where your house is. No, I know your property is.
Yeah, your dog took us.
You made your dog stick out.
Your description is not about
Yeah, it is.
No, it's not.
It's one. Okay, it is 1. 1.
It's just the
Yeah.
what number
And
was
then you look where the extra.
I don't know. 245.
Positive 1. And then 1. 1 and negative 2.
If I didn't screw up my mental math, there should be all 4 are rational.
There's 4?
Yeah, we were just gonna make out the guess that.
I just type it in.
Maybe I screwed up. Let's see, 6 squared. 8 minus 3 is 5, minus 4, correct. Minus 1 plus 1.
There's a remaining two. If you go to the table, y doesn't equal 0.
You're done. So, and it doesn't matter if it's plus or minus.
I got 6, negative 7.
Plus or minus
Yeah. Alright, we're going to see where this goes. The last 2 signs were supposed to be swapped. I missed a negative. I missed a negative, so that I have no idea what the answer is going to be.
No, it's negative 2.
I missed a negative, so I got no friggin' clue what this is going to do.
And then we put it
Okay,
in.
guys, you plug in 1.
Spin 2.
You plug in 1.
2
Just plug in 1.
So I don't need repeat. I don't need Where'd you get 2? This guy.
Okay, let's talk about possibility. How do I find the possible rational zeros? Come on, meow. All the factors of what? Okay. All the factors of your constant, so 1, 2, and 4, over all the factors of your leading coefficient. 1, 2, 3, and 6. So when I write that out, potentially I have all that junk over 1, all of it over 2, all of it over 3, all of it over 6. Whew. 1, 2, and 4. 1 over 2. 2 over 2 is 1. I don't need to write it again. 4 over 2 is 2. I don't need to write it again. All that junk over 3. 1/3, 2/3, 4/3. All that junk over 6. 1 over 6. 2 over 6 is 1/3, and I already have it. 4 over 6 is 2/3, and I already have it. So there's all my possibles. Then I need to gaze into my crystal ball and say 6, 5, -10, 5, -4, and say, boy, I feel lucky about what? And I look at my calculator and I say, that's awful close to, what was it, 2 or negative 2? Okay, it looks super close to negative 2. So I'm going to try negative 2. And wait a second, it didn't come out clean. So it wasn't actually negative 2. You try the other one that it looks like, and it also doesn't work. So then I would say this is my possible rational zeros. The actual rational zeros, oh, there are real numbers. It crosses the x-axis. There's no rational zeros. Because the ones that were the closest to where it looked like, they didn't work. So I can't use those. Now, let's say I backed all that up. This will not change. And what if I did a little bit of an oopsie like that? Now try.
Oh, you gotta be pooping my butt.
Minus 5x plus 4. Because a negative 1 times a positive 5 is a negative 5. And I teach math for a living. So all the possible rational zeros are still the same. That hasn't changed. But when you go to check things, okay. Yep, all the possible zeros are still the same, but which ones actually work have definitely changed. The difference a negative can make.
Like a half, probably.
Do this.
Huh?
Whoa. Whoa. This is fast. Yeah, I know.
And I gaze into my crystal ball. I feel awful confident about 1 and negative 1. And say, I got a feeling about 1. Okay. Now, I want to show you something we have not covered yet. Most of you, if you're checking for which ones work, are you doing 4 separate synthetic divisions? I am here to tell you, you don't have to. And that's why we had to know synthetic division, as opposed to just long division. Side quest. What's 2 times 3 times 4 times 5?
120.
You sure?
168. 132. What's 120?
Yeah. Okay, so it's 120. Now, what would happen if I took 120 divided by 4? Isn't that 2 times 3 times 5?
Yes.
What if I took that 120 and I divided it by 3? I'd have 2 times 4 times 5. So if I divide by a factor, aren't all the other factors still there in whatever's left? That allows me to keep going in a chain like this. We said we also felt lucky about -1, right? So -1 should go into what's left after I take the 1 out. Try it. -6, 5, -5, -4, 4, 0.
Mine didn't do that.
If I took my polynomial and I divided it by x minus 1, then the cubic that's left over should still have the other 3 zeros in it, right? So I keep going in a chain like this. If I feel lucky about a 1/2, I should now be able to use a 1/2 on what's left. And since I divided by 1/2, if I feel really lucky about a -4/3, and then if I divide it by 3, I should divide by 3. Okay. This is how we're going to be able to solve polynomials. It's not enough to just say this thing is a 0. If I divide by that 0, I get what's left. And if I divide by the next 0, I get what's left. And I keep doing that until there is nothing left. I have found all the solutions. And you say, but I did 4 different problems. I found them. What's the big deal? Why can't I do them separately? What happens when it's not a rational solution? What happens when it's an imaginary number? You're not going to find your irrational and imaginary zeros by doing them separately. You have to do them in a chain until you hit a quadratic. And then that quadratic can be dealt with however you want. Whether that's by factoring, or by quadratic formula, or complete the square. It's not always going to be something with rational zeros that you can do in synthetic division. In fact, trust me, you do not want to do synthetic division with complex numbers. It is disgusting. So, can you find the rational zeros? All right. Next part. So we're going to kind of create this, what I just showed you, we're going to create that kind of in reverse here. It's called conjugate root theorem. I know that this looks very gross, but it says if a plus square root of b is an irrational root, then its buddy, its conjugate, a minus square root of b, is also one of my roots. You tell me why, if square root of 5 is a 0, then negative square root of 5 is also a 0. Why do I know they have to? Okay. What am I about to do? Plus or minus. To get a square root, I had to put in a square root. And if I had to put in a square root, there was a plus or a minus. So that also means when I like solve by blah, 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 blah math, and then get x minus 1 squared is, I don't know, negative 3. Okay? Complete the square. Blah, 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 blah. I get down here. Or quadratic formula. What's up? When I square root and I solve, it's always been that plus or minus, meaning two of them. Meaning if 1 plus I root of 3 is one of my zeros, then I know 1 minus I root of 3 is also one of my zeros. That's the conjugate root theorem. And they're called conjugates because if I take this times this, remember that from back in chapter 4? 1 times 1 is 1. 1 times I root of 3 is, or negative, I root of 3. I root of 3 times 1 is positive I root of 3. I root of 3 times negative I root of 3 is negative I squared, square root of 3 squared. Remember when all of that stuff canceled out? Like that? We worked with conjugates before. Conjugates are special in that they will usually, always get rid of middle terms. They'll get rid of the radical terms or the imaginary terms that you don't like. For anyone who is all about, I like smashing numbers together and multiplying things and just writing out a bunch of letters and numbers because it moves it around on my paper and I know how to do that and it makes me feel smart. You're going to love this. A quartic polynomial has those two. If I've got square root of 2, who else has to be a 0? If 1 plus I is a 0, 1 minus I, its conjugate buddy, is also a 0. Go. If you know those zeros, if it helps to have the parentheses there, what else do you know has to be a 0? Anything that's got a radical in it, including I, because I is squared negative 1, its conjugate is also a 0. So 3 minus 2i is a 0. What else? 3 plus 2i. If 5 halves is a 0, what else? Says who? Does that have a square root in it? Does it have an I in it? So the conjugate root theorem does not apply. Only when, that's actually a wonderful reason. When I did my battery of testing, some of the questions were super stupid and very white Eurocentric. Like, we're going to test your knowledge and say, who wrote Hamlet? Pretty sure it's Shakespeare. Who wrote this other thing? Oh, some dead white dude. Who wrote this sonnet? Another dead white dude? Like, why are you asking me this? Because it's the correct answer, a dead white dude. Right? In this case, 5/2 is not a zero, or it's not a radical zero. It doesn't have a square root in it. It doesn't have an I in it. So don't worry about the conjugate root theorem because it doesn't apply. Conjugate root theorem only applies to things that have radicals in them. Now, why would I need to know that? Dun, 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 dun. If you write big, you might want to move to a separate sheet of paper. If you write big, you're going to want a separate sheet of paper. Okay? Which of these has the roots of -4 and 2i? Now, since we're approaching the season of standardized testing, what if I ran across this right now knowing only the knowledge that I know? How could I check which of those has a -4?
You can square find the
How do I know something's a 0?
quadratic formula. Set it to 0.
Those aren't quadratics, Haas.
You change it to a quadratic and then plug in.
What did we just get done doing?
The synthetic.
Do synthetic division and see if it works. Now, if you didn't know anything else, you would now have to do synthetic division on all of these with -4. Do not write this. Okay, it works in that one. Do it again. Do it again. Do it again. Hey, now that I'm here, I have x squared minus 6x plus 8. Does that have the zeros 2i and -2i? Do you want to do that 4 times? No. No. So instead, I'm going to use this idea that if I know the 0, I can get the linear factor. If I know that -4 is one of my solutions, one of my zeros, one of my x-intercepts, one of my roots, what's the factor that made it? Y'all hurt me. Y'all hurt me deep. X minus the 0. That's the factor that made it. Okay. He said big words. Okay. If I know the 0, all right, at the top of this page, please write this. X minus the 0 is a factor. X minus the 0 is always a factor. Y'all, we did this last week. Remember when we said, what if x equals 2, -2, 3, and 1 make the polynomial? Right? Okay. Every time that we did that, it was rational numbers. Now they're going to be irrational numbers and imaginary numbers. It's still the same process. So, if I know that x equals -4 and 2i. Yes. What else has to be a 0? Conjugate root theorem. -2i. Why do I not put positive 4? Not a square root, not an imaginary number. Conjugate root theorem doesn't apply. Now, if I know that x minus the 0 is always one of my factors, I can say x plus 4 is one of my factors. What else is a factor? Okay, x minus the 0, x minus the 0. Okay? X minus the 0 is my factor. Right now, the factors aren't terrible. Now remember, if I had something like 3 times 5 times 274, you would probably multiply together the two things that you know go together, right? I would say 15 times 274. I would actually say 10 plus 5 by 200 plus 70 plus 4. But that's me. Okay. I'm going to multiply together the two things that go together, which are the conjugates. Take x times x, x times 2i, negative 2i times x. Forgot my x's. Negative 2i times 2i is minus 4i squared. This is why conjugates are nice. I might start with an imaginary 0, and that ain't pretty. But when I use conjugates, stuff happens like cancels out. What is I squared again? So it changes that into x squared plus 4. Now, we still have this guy to contend with. But now isn't that just multiplication like we were doing last week? Okay. So I'll take x times x squared, x times 4, 4 times x squared, 4 times 4. My polynomial is x to the third plus 4x squared plus 4x plus 16. I'm not going to get that polynomial by guessing and checking. Okay. The one directly below that. I'm going to do it again. Is anyone going to get weird on me? Y'all good? Almost there? Okay. I am going to go through this one with you because it gets worse than the last one. Why might this be more difficult than the last one?
Like they're not all singular terms.
Right. Before it was just 2i. Now it's 2 minus 3i together. So we know that this is x minus 8. We know that this is x minus 2. Right? Like, we know that. Remember that it's always x minus the 0. So if I have x minus the 0, the 0 right now is 2 minus 3i. If that's one of my zeros, then its conjugate buddy, 2 plus 3i, is also one of my zeros. Do you see where this is going to start getting a little hairy? It's not that it's super difficult, it's that there's just so much stuff. It is just distribution. So stage 1, I would want to distribute this negative. So I have x minus 2 plus 3i. I would want to distribute this negative. So I have x minus 2 minus 3i. I also have, these two haven't changed, x minus 8, x minus 2. So I've got to multiply all that stuff out. It makes more sense to multiply together the things that go together, right? So if I multiply the green stuff together, x squared, negative 2x, minus 8x, plus 16, getting x squared minus 10x minus 16. Cool? I even said it right there. God. Okay. Where's my marker? Is it still back here? I did not put the last one up there.
Ooh, we're coming back.
Okay.
Yeah, because that's like your first class of the day. I feel like that'd be nice.
We also just hit the new stuff,
Oh,
so I don't know how they're gonna. I don't know if they're gonna keep up the pace, but that's also a really good crew. Like, we'll see what happens. All right, this one. I've told you before that we need some method of organization to how we're going to multiply things. Right? So follow me as we have some form of organization. If I take x times that stuff, x times x times negative 2, negative 2x, x times negative 3i, negative 3ix. It's starting to get weird, right? Trust me, it's all going to work out at the end. Now, take negative 2 times the stuff. Negative 2 times x is negative 2x. I'll write it right here because they are like terms. Negative 2 times negative 3i is plus 6i. It doesn't go with this, right? Because it doesn't have an x. So I'll write it over here. Or 6i, we said. Take negative 2 times, we completely missed, negative 2 times negative 2 was, here, I got to move this over. Yeah. Negative 2 and negative 2 was plus 4, and then negative 2 and negative 3i was plus 6i. Okay. Do again. 3i times x is a positive 3ix. I'll write it here because they're both ix. 3i times negative 2 is negative 6i. I'll write it there because they're like terms. 3i times negative 3i is negative 9i squared. Conjugates do cool things, like cancel out all the crap you don't want there. If I look at this now, my IX terms cancel. My I terms cancel. I get x squared minus 4x. I squared is a negative 1. 4 plus 9 is 13. Okay. But we still have quadratic times quadratic. We have to keep going. Well, degree 2 and degree 2 makes degree 4. Quartic. Close. So now I have this times this. Really, that's the thing you want to get rid of? Okay. And I multiply that out. I take x squared times this stuff. X to the 4th minus 10x to the 3rd plus 16x squared. Everyone following with? It's a lot. It really is a lot. I understand. If I'm going too fast, you got to stop me. Take negative 4x times the stuff. Negative 4x times x squared is negative 4x cubed. Negative 4x times negative 10x is plus 40x squared. Negative 4x times 16 is minus 64x. Almost there. 13 times the stuff. 13 times x squared is, well, 13x squared. 13 times negative 10x is negative 130x. 13 by 16 is 130, 60. You sure? Yeah, it is. Getting my final answer, my polynomial is x to the 4th minus 14x to the 3rd plus 69x squared minus 194x plus 208. Woof. That is a lot. Like, normally one of your problems on a quiz is like 6 problems, 5 points each. You're probably looking at one of these problems being more like 8 or 9, and there's just less problems on the quiz. Okay. Now, I'm going to side quest here and give you something that every Algebra 2 teacher worth their title shows kids. What I'm about to show you, I've also never seen in any math textbook, ever. But every algebra teacher knows this. I've never seen it in the textbook, ever. I want you to look at what happened over here in the purple stuff. When I multiplied these two conjugate zeros with each other, you notice how this stuff canceled? And that canceled? And I had 2 of these? And 4 is 2 squared. And 9 is 3 squared. There's a formula. The formula does not exist in any math textbook. But I can take all of this out and go directly here. Okay? I'll show you. Now let's say I had generic A plus BI. That's one of my zeros. What's the conjugate?
A minus BI.
And if this is a 0, then x minus that is one of my factors. If that's a 0, then x minus that is one of my factors. Follow so far. Distribute your negatives, getting x minus a minus bi times x minus a plus bi. Go distribution bonkers on it. X times x. X times negative a. X times bi. This is just going to be alphabet soup. But watch what happens after the alphabet soup clears up. Negative a times x. Negative a times negative a. Negative a times bi. Negative bi times x. Negative bi times negative a. Negative bi times bi. Look at what happens here compared to what happened on our problem. Cancels. Cancels. Two of these. This squared and the I squared changes my sign. Now let's say I went all the way back to my original 0 and didn't want to do all that work. X squared minus 2ax plus a squared plus b squared. A is 2, b is negative 3. 4 plus 9 is 13.
OMG. It's almost like we could have used that about 10 minutes ago.
Do you understand where it came from now? What if I decided to just not show you this because it's never anywhere in your book? Because it's never anywhere in your solutions?
Looks like we're doing a lot more work.
Yeah. So, I would like you to write down a pair of cheaters and like highlight, neon flash and sign. You're going to need this. I'm going to write it again. I'm going to write this. I'm about to write this. Chill. I'll leave it there just to annoy kids. If I have a plus bi as an imaginary 0, x squared minus 2ax plus a squared plus b squared is the quadratic that made it. If I did all of that same stuff with any radical that didn't have i's in it, the same thing would happen, but at the very, 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 very end, I wouldn't have that I squared there to change the sign. So if I ever have a plus some radical b as a 0, the same thing will occur, but I won't have that I squared to change my sign. You're going to want those written down. You're going to want to get familiar with them because it is nowhere. I've never seen it in a Algebra 2, college algebra, or pre-calc textbook. Okay, I took Algebra 2, when the crap was that? 21 years ago.
Should there be a plus or minus before the B?
No. Because it doesn't matter whether B is a -3 or a +3, what's going to happen when I square it? It's saying if this is a 0, I know that A minus BI is also a 0. If those are two zeros, I can blah, math, and I'll get here. I don't need to write the conjugate out at all because I know this is where the conjugate leads. Y'all are teenagers. You know if your parents start a conversation a certain way, you know where this is going. Okay? Harrison, come here, dude. We need to talk. And you're just like, oh, hell. Like, you know where that's going, right? What are you taking away and for how long? Okay. The fact that you got worried and you were like, me? Yeah, you probably shouldn't do that. So, but, you know, make choices. Y'all got it written down? Okay. So, skip over this, go to this page. We're going to come back to this. Come here. Up here. 28. If you write small, probably want a separate sheet. The way that the book wants you to do this, do not write this, is x minus 3 plus I times x minus 3 minus I times x minus 1 minus square root of 3 times x minus 1 plus square root of 3. And then go distribution bonkers on it. I want you to be aware, this is how the solutions look in your book. What you're going to do is skip about 5 lines down, and you're going to look for the quadratics. The quadratics will be x squared minus 2ax plus a squared plus b squared times x squared minus 2ax plus a squared minus b squared. Because this has an I, so I will have a plus in between a squared and b squared. This does not have an I, so I will have a negative in between them. Identify, if this is a plus bi, what is a? What is b? 1. Not 1i. Remember, it's a plus bi, the thing in front of b. Don't put the I there, or that will change your signs. Just put a 1 there. Which means if I complete my formula, this is x squared minus 6x. 9 plus 1 is 10. I was able to skip about 5 lines of nasty work. In here, what is a plus b? B is the entire radical, okay? A is 1. B is the entire radical, square root of 3. I don't like the way that I've always written that was just a plus b, where b is a radical. And some kids just can't get it wrapped around their head that the entire square root of 3 is the b. Yeah.
So how do you tell whether it's a plus or minus sign in terms of like the
I or no I?
that's it?
Yeah. If there's an I, it's plus. If there's not an I, it's minus. Because at the very end of that formulaic structure, the I squared is what changes the sign.
Oh yeah.
Okay. So over here, I do on my multiplying, and I get x squared minus 2x, 1 minus 3. And then you can multiply that, right? So it cuts out, depending on the problem, anywhere from a half to a third of your work. X squared times all the stuff. Negative 6x times the stuff. Ten times the stuff. Combine like terms. X to the fourth minus 8x to the third. What's that? 20? Yeah. 20x squared minus 8x minus 20. I told you. I did not leave nearly enough space on here. Okay. Now remember, you use those cheaters if it's either a complex or compound root. If it has an I or a radical. If it doesn't, it's just what we were doing last week. If I just say 3 plus I and 5, I do the cheater for the 3 plus I, and then I'll have an x minus 5 over there. Okay? I'm going to set you loose. But I don't like theirs. One plus 2i. 1 minus square root of 2. I'm still keeping the number small, but you got to use the cheater on both. Go. X squared minus 2x plus 5. It's a boatload of writing. It's not that it's terribly difficult stuff, but man, there's a lot of moving parts.
going.
Like,
So for the first equation B, what y is changed? Right. Did you put 2y? Did you put 2? I squared.
double reverse in. SpaghettiOs. We called it SpaghettiOs because it was a giant mess.
Because then the x can get to
Double reverse, drop it off on us in. So as everyone is coming up here saying there's obviously some sort of reverse shenanigans, we must kill it. You dropped it to him and off he goes. It's a giant mess, but if it works right, touchdown. Okay. Say x squared minus 2a x plus a squared plus b squared times x squared minus 2a x plus a squared minus b squared. Okay. You set up your form. There's your practice. Plug in A and B. Plug in A and B. Be careful that it's the entire square root of 2.
Wait.
A plus B, I. B is the coefficient of I. Don't put the I in there. Turn that into x squared minus 2x plus 5. X squared minus 2x minus 1. Did you get to green? Use the cheater to get your quadratics. This is cutting out 2/3 of your multiplication problems. Once I'm there, distribution town. X squared times the stuff. Negative 2x times the stuff. 5 times the stuff. Combine like terms. I didn't put a negative on it, so it's positive. Right?
Yep.
Okay. So plus 7x squared minus 8x minus 5. Oh, did I do it dumb? There's a lot of moving parts there.
Seems right.
I think it should be 8x squared.
On the top row blue.
Top row blue?
Yeah, negative 2x squared. It should just be x. It should just be x.
Yeah, it is.
That's why
So there's a lot of stuff there. To be fair, that's exactly where he started asking me questions about up there.
Wow. That's a brownie point. Definitely not.
We were having trouble with the I there.
Oh yeah, because I was making sure that these guys.
No, it's a valid question to ask, but that's where that came from.
Flip for a coin to see who gets the brownie point. How would I?
No, he's asking a legit question. That's on me. I'm distractible. Yeah. Uh-huh. Okay, yeah. Technically it is. I get lazy and never write it because when I square it, it's always going to, yeah. No, you are right. Where is it? There we go. Yoink. Wait a second. But yes, I did do the goof. So.
We are maxed out.
So. Y'all, this is super tough. I hate saying you're probably looking at one of these on an ACT.
Taking like 20 is 10 minutes. What do I do?
No.
No way.
Are we doing number 32?
If we do number 30, I'll just do it up here.
No,
You know what? I'll just leave that one as 5i.
What is that?
Pog Slammer, circa 1992.
That's cool.
Mm-hmm.
So on this one, I messed up here, like getting the negative one.
Uh-huh.
I got -2 instead, and I was just trying to you got the -1. Because other than that, like I got the rest of it,
Right here.
I just messed up there.
Square root of 2 squared is just a 2. 1 minus 2 is -1. What we might have done is been brain fried by the time we hit here. Said 1 squared was 2. Square root of 2 squared was 4. 2 minus 4.
Because I said 2, I think I might have just ignored that.
Oh, might have just not even seen that.
Zoe about this one, and I said 2.
It is convenient to blame someone else for your mistakes, isn't
No,
it? I do it all the
wasn't
time.
trying to blame her. I was just saying I was talking to her about it because I was asking her like how you did this. I asked.
I was speaking more of myself because I blamed Caden.
I was like, because I was just asking like it would be 2.
Yeah.
And then I just.
Yep. Just oops. That's also why when I look at these, like say for a daily quiz or your quiz, like my steps are, I'm going to look at, did you set up the formula? Did you get the quadratics right? Check through your work, then the final answer. If you had a -2 here, but all of this stuff was correct based on that, I would just say 1 off. But you did everything else right. There's just so many moving parts.
Because I realized I got those two wrong, and then I was trying to go back to figure out where.
Yep.
I messed up.
Hi, what?
Is A5 and B 1?
Or is A1 and B's 5?
A is 0, B is 5.
B is 5? I was wondering if one was 0.
They like it simplified around.
A is 0.
And B is 5. I had that right.
Yo,
I have a question.
I have an answer.
Can I, when I see this, can I just like do that?
Yes.
Get root 12, so it just
Yeah,
makes
because
it
you
easier.
square the outside and the inside. But when you square the outside, you have 2 of them. When you square the inside, you just get the radicand.
Mhm.
Yeah, if that's what works for you, do it. What's that? 16 minus 12?
That's so cool. What? No, actually.
Okay. So, your homework. Expect a little bit of work with the whole rational zero, confirm the zero thing, and then practice on this. Not a boatload of it, but enough.